So following on from the previous video, I asked the question which would give me a bigger volume, me rotating this area here, me rotating it along the y-axis, or me rotating it along the x-axis, which would give me a bigger volume. So rotating it along the x-axis, along the y-axis, will give us a volume of this, will give us a volume of this. So now we're going to look at it as we rotate it along the x-axis. So now we're going to rotate this area here along the x-axis. Okay, so rotating this along the x-axis, So we're going to sum up all the disks in this case. Okay, we're going to sum up all the disks. So we're going to sum up all the disks. So that will be from 0 to 2. Okay, and if you let's just look at one particular disk here. Let's just look at this one here. The thickness associated with this will be dx here. So it's going to be something dx. Okay, and then the height here, the height of this thing here will be given by this. So really the disk here, as you revolve it around here, the area of the disk will be pi the height here squared. So pi the height here, hang on, oops, x here, pi the height here, squared. So this here will give us the volume of this solid as we revolve it around the x-axis. So the volume of this thing here, the volume of that solid will be given by this. Okay, will be given by this. So it's really us getting pi r squared, but r is the height. So the height. So it's really pi r of this thing here. So when you get pi the height squared, it will give you the area of the circle. Well, anyway, if you revolve this around the x-axis, it will give you this volume here. So the volume is given by this. Okay, and now tidy this up. So this is really getting this timesing by itself. So that will then give you this, removing the square root. Okay, and also pi is a constant. Take it out, and then now it's just a matter of integrating this. So visualize this as this. Actually, you don't actually need this step, but it doesn't matter. Visualize it as this. So now integrate it. So just notice that when you look at this, when you differentiate this, it gives you that. So really, what you've got here is 1 over x. Hang on. To the power of 3 plus 4. So what you've got here is this thing here. So you need to search for something that when you differentiate it, it will give you something similar to this. Well, your initial guess should be the natural log of x to the power of 3 plus 4. Should be the modulus, but I don't think we're going to be concerned with the negative side. So let's just make this to be our initial guess. Natural log of x to the power of 3 plus 4. Make this to be our initial guess. So now, hang on, make this to be our initial guess. So wait there. So remember, we are trying to integrate this. So we are going to make this to be our initial guess. So when we differentiate this, it will give us 1 over this bubble here, which will be x to the power of 3 plus 4, and then times with the derivative of the bubble itself. It's us using the chain rule. So it will be 3x squared. Okay. Yeah. So now we now this gets multiplied to the top. So that would be hang on. Well, actually leave it like this. So now now we need to get rid of this 3. Let's get rid of that 3. So that then make our adjustment to our initial guess. So if you were to differentiate this now, it would give you this thing here. Okay. So notice that this matches up with this. This thing here matches up with this thing here. We still need this 16 here. So make the adjustment 16 here. So 16 over 3. Well, when you differentiate 16 over 3 of this whole thing here, it will give you this thing here. Okay, so anyway, integrate this thing here, it will give you this. So hang on, integrate this whole thing here, it will give you this thing here. Okay, so now it's a matter of getting this, take away this, and then times pi. That will then give you this thing here. Jump to your calculator, and it should give you this. So the rotating it along the x-axis would give us a volume of 18 point whatever. Rotating it along the y-axis would give us a volume of this. So as it turns out, hang on. As it turns out, it would give you a bigger volume if you rotate it along the y-axis. Okay.